Hello and welcome to another 7-in-a-Box video demonstration. My name is Dan Flesick. Today I want to show you a selection of minerals from the Geology kit that all share a very interesting property called fluorescence. These minerals mostly look like dull, ordinary rocks in regular lighting, but they absolutely come alive under black light. It's really amazing to see it in person, because it can be kind of hard to believe if you're just watching it on a video like this. I'll show you how it works, explain a bit of why it works, and hopefully you'll get to see it for yourself in your classroom with this kit. This kit is pretty simple. It comes with 2 blacklight flashlights and 1 box of minerals. The box contains an explanation of what the kit is, a key sheet that tells you what all the items are and what colors they glow, and 15 different minerals, which are all labeled. You might notice on the key sheet there are 2 columns. There's one for shortwave and longwave. These are different types of ultraviolet or UV light. This flashlight and just about every other blacklight that you've seen is a long wave UV light, and it's totally safe to use. It's that purple color that you've no doubt seen before. The other type, shortwave, is actually dangerous for your skin and eyes. It's a lot like getting a concentrated dose of sunlight, so it can very easily burn your skin and damage your eyes. Unfortunately, not every mineral in this box will glow under this included long wave light. You see there's gaps on the long wave column here. So you won't be able to see everything glow, but I do have a short wave light here that I'll show you later on. The glow of these minerals is best seen in a dark room, so I'm going to turn out the lights. You can also build a viewing box out of something like a big opaque storage tub with a hole cut in the lid. That makes it nice and dark, but then of course you can only have one person at a time look at it. So it's whatever works best for you. So I took all of my minerals out of the box because it's a lot easier to see it on camera with a black background, but you can leave yours in the box when you do it. So this is what everything looks like under regular lighting. And now let's see what they look like under the included long wave flashlight. Some of them light up pretty significantly, especially number 13 down there, super pink, very cool. Now that kind of overwhelms the camera a little bit, so I'm going to go in with a smaller long wave light that I have and just illuminate each one individually. See, these first 2 give really nice little splotches of orange, pinkish orange, I guess. Don't see much from 3. 4 lights up pretty nicely. It's like a pale, a green, I'm going to call it. So I don't get anything from 5 or 6. 7, we get a very faint orange. I don't see anything on 8 or 9. 10 though glows nicely. That's like a purplish blue, which might be hard to see on camera, but it's very cool in person. I don't see much on 11, but the key sheet says you should, so maybe your sample will be a little bit nicer. Nothing on 12. 13 is the really nice pink color there. And I don't see anything on 14, but 15 we've got a couple of cool yellow regions. So that's neat. That's pretty amazing, isn't it? I think it's incredible that ordinary looking rocks can light up so beautifully when you use just the right type of light. But why does this happen? Well, it has to do with the atoms that make up the mineral. Don't worry if you haven't learned about this yet. I'll try and simplify it enough so it's easy to understand. So atoms are made up of a nucleus surrounded by electrons. The electrons will stay at certain distances from the nucleus, which looks like planets orbiting around a sun. But if a ray of light comes in with enough energy, say from like a black light, and it hits that electron, it can kick that electron up to a new level. So now our electron is excited, it's called. It's a higher level and it's got more energy than it would normally have. Now, once the electron is up at that higher level, it's eventually going to want to fall back down to its original level. So when it falls back down, it has to lose that energy that it gained to get up there in the first place. And so it releases that in the form of another light ray. And it's usually of a different wavelength, and that makes it a different color. So when you shine ultraviolet light on these minerals, which is invisible to us, it then gets released as a color that we can see, like the orange or the yellow that we saw earlier. Pretty neat. Now my flashlight is also able to do shortwave light, which, as I said, is much more dangerous. So I'm going to be wearing UV safety glasses, and I'm going to be sure to not point this light at my skin or eyes. So this isn't something that you can do, but I really wanted to show it to you because it's very cool. So let's see what these look like under this different type of light. So these first two don't do anything. Remember, these are the pink ones under the long wave. 3, we get some awesome greens. Maybe a little bit of cream on 4 and 5. I don't see anything on 6 and 7. But 8, check that out. Green and red. We didn't see any of that under the long wave or visible light. So that one's fantastic. And then the rest of these glow a little bit, but not too spectacularly. Especially 13, we still get a bit of a pink, but not anywhere near as vibrant as the long wave. So you'll be able to see a better color on that one. But the two main ones is 3 and 8 here. We get the greens and the reds that you don't see anywhere else. So that's about it for this activity. I think it's incredible that such vibrant colors are there in these rocks, just hiding in plain sight. I wonder what other crazy colors you might be able to find in your own backyard. I hope you learned a little bit and enjoyed this activity, and we'll see you next time.